Hello everyone. So in last lecture we discussed Laplace transform of a step signal and also we discussed some properties of Laplace transform of a step signal. Now in this lecture we will discuss some examples on Laplace transform of a step signal. So let us start with the first question. The first question is, find the Laplace transform of the pulse signal shown below. You have a pulse signal from minus A to plus A. Its height or magnitude is 1 and the signal is given by R of t and it is u of t plus A minus u of t minus A. So u of t plus A and u of t minus A, there is a time shifting. So we have already seen the time shifting property in a step signal, which is u of t minus t naught. Its Laplace transform is e raised to minus st naught upon s. So using this property, we can easily find the Laplace transform of the signal r of t. So let us find the solution. The signal is r of t is equal to u of t plus a minus u of t minus a. We have to find the Laplace transform of the signal r of t. Now you can compare u of t minus t naught and u of t plus a. The Laplace transform of u of t plus a will be e raised to minus s, and instead of t naught, here it is a. So it will be e raised to minus sa upon s. So the Laplace transform of u of t plus a will be e raised to sa upon s, and Laplace transform of u of t plus a will be e raised to minus sa upon s. So we can write the Laplace transform of r of t will be r of s, and it will be e raised to as upon s minus sign as it is into e raised to minus as upon s. So this is the Laplace transform of the given r of t signal. Now let us go to the next question. The next question says, find the Laplace transform of the pulse signal shown below. Here again we have a pulse signal and it is from 2 to 7. 2 is the lower limit. 2 is the lower limit. And 7 is the upper limit. And the important thing, the height of this pulse is 5. In earlier example, in example number 1, the height of the pulse signal was 1, but in this example, the height of the pulse signal is 5. And we are given with the signal r of t, it is 5 u of t minus 2 minus 5 u of t minus 7. We have to find the Laplace transform of this signal. Again, there is a time shifting, so we have to use the time shifting property, and we know the property. It is u of t minus t naught. Its Laplace transform is e raised to minus st naught upon s. So we can find the solution. It is r of t is equal to 5 u of t minus 2 minus 5 u of t minus 7. So again, if you compare this u of t minus 2 with u of t minus t naught, the property, the Laplace transform of u of t minus 2 will be e raised to minus 2s upon s this 5 as it is. Again, the Laplace transform of u of t minus 7 will be e raised to minus 7s upon s. Again, this 5 as it is. So finally, the Laplace transform of signal r of t will be r of s, and it will be 5 e raised to minus 2s upon s minus 5 e raised to minus 7s upon s. If you want, you can just rearrange these terms. So r of s will be, you can take 5 common and s also common, 5 by s in bracket e raised to minus 2s minus e raised to minus 7s. So this is the answer for the Laplace transform of the given question. So the third question is, find the Laplace transform of e raised to minus 80 ut. So let us find the solution for this question. These are all basic questions on Laplace transform of a step signal. Now it is e raised to minus 80 ut. So ut is multiplied by an exponential signal e raised to minus 80. So we can use the shifting in S domain property, or it is also called multiplication by exponential signal. So we have the property, it is e raised to s naught of t is multiplied by u of t. Its Laplace transform is 1 upon s minus s naught. So using the same property, e raised to minus 80 u of t, we have to find its Laplace transform. Now we know the Laplace transform of u of t is 1 by s. So when an exponential is multiplied in time domain, it results in shifting in s domain with opposite sign. So it will be 1 upon s. So it is shifting with opposite sign. Here the sign of a is minus. Here it will be plus a. So the Laplace transform of e raised to minus 80 ut is 1 upon s plus a. Here we can also find the graph of e raised to minus 80 ut. So at t is equals to 0, it will be e raised to minus 0 into u of 0. E raised to 0 is 1 into the value of step signal at t is equals to 0. It is also 1. So it is 1 into 1. So it is 1 at t is equals to infinity. So e raised to minus infinity into u of infinity. E raised to minus infinity is 0 into u of infinity is 1. So it is 0. So if you want to plot e raised to minus 80 ut graph, it will be something like this. These are my axis. This is the time axis t. Now at t is equals to 0, that means at origin the value is 1. So I can mark this as 1. And at t is equals to infinity, the value is almost 0. So it is approaching the 0. So it is nothing but an exponentially decaying signal. So this is my e raised to minus 80 ut signal. Now since there is u of t, it will be a right-sided signal, and also it is absolutely integrable. It is absolutely integrable and it is a right-sided signal. So this is a stable signal. So e raised to minus 80 ut is a stable signal since u of t is a right-sided signal and it is exponentially decaying, hence it is absolutely integrable. So let us see the question number 4 now. So question number 4 is find the Laplace transform of e raised to plus at ut. So the only difference between this question and the previous question, it is only of the minus sign. In previous question it was e raised to minus at ut. In this question it is e raised to plus at ut. So again we can find the solution of this question. Again, we have to use the property of shifting in S domain. So I can write e raised to at ut, its Laplace transform will be, we know the Laplace transform of u of t is 1 by s, and if there is an exponential multiplication, there is a shifting in S domain with opposite sign. Here the sign of a is plus, but in Laplace it will be minus a. So the Laplace transform of e raised to at ut is 1 upon s minus a. We can draw the signal e raised to at ut. So at t is equals to 0, it is e raised to 0 into u of 0. So it is e raised to 0 is 1, u of 0 is 1. So the answer is 1. And at t is equals to infinity, it is e raised to infinite into u of infinite. E raised to infinity is infinity into 1. So it is infinite. We can plot this signal with respect to the time axis. E raised to at ut is also called exponentially increasing signal. And since this e raised to at ut is a right-sided signal, but it is not absolutely integrable, because at t is equals to infinity, the value goes to infinite, hence it is not absolutely integrable. Hence we can say e raised to at ut is unstable signal. So I hope you have understood these basic examples on Laplace transform of a step signal. In next lecture, we will discuss the Laplace transform of the second basic signal, which is nothing but the ramp signal. So see you in the next lecture.